In this video, I'm going to show you how easy it is to deploy Docker containers onto AWS. I'll be using an open source project I've been working on called fargate CLI. With one command, you could deploy a container and start interacting with it through its public IP address, and with just a couple of commands, you could deploy your application as a highly available service. Let's start with a really simple one. Let's say we want to run a public Docker Hub image as a container in AWS quickly. In this example, I'm going to use the web server Nginx. We can do this with one command. We've started a new task called Nginx, and we've used the latest Nginx container image from Docker Hub as our image parameter. Let's take a look at our task. Here we can see attributes of the task, including its ID, the image it's running, CPU and memory configuration, and its public IP address. The task status is provisioning, which means the task is starting. Let's watch it a moment as it boots up. The task is now running and ready to process requests. Let's give it a shot with curl. Looks like Nginx is up and running. It returned the splash page that Nginx replies with by default. But how can we see what our container is doing? Let's retrieve our container's logs. Here is the access log showing us details about the request we made just a few seconds ago. We can also watch the log to see messages as they arrive. Let's run curl a couple of more times while tailing the log. When we're finished, we can also stop our task with one command. Let's look at another example. Let's say we have a local project with a Docker file, and we'd like to quickly run it on AWS. Our demo project has two files. Index.js has a tiny Node.js app that creates an HTTP server. For any request that server gets, it returns hi there and logs the request, and it listens on port 8080. And a Docker file that builds a Node container, adds our application code, and configures it to run. When the image parameter is not supplied, task.run will build the project in the current working directory, push that image into a private repository, and run it. And by using curl again, we can verify that it is running. Next, we're going to create a service for our demo project. The service will maintain multiple containers for our demo project and will integrate with a load balancer to distribute traffic across them. First, we'll create an application load balancer. We can do this using the fargate lb create command. Here we're creating a load balancer called app that's listening on port 80 HTTP and port 443 HTTPS, and I'm passing it a certificate that I created earlier using the fargate certificate request command. Next, we'll create our service. When creating our service, we'll specify that the container will be listening on port 8080, and we're going to configure the app load balancer, and we're going to tell our service to maintain a count of 4, so we'll have 4 containers running at all times. Now that our service is created, let's find the DNS name for the load balancer and give it a go. And it's responding through the load balancer. Let's follow the logs and hit it a few more times so that we can see multiple containers responding to requests through the load balancer. Each log line is prefixed with a task ID, which is rendered in its own color for easier correlation. Let's create a friendlier hostname for our load balancer by creating an alias record in our own domain. Because my domain is hosted in Amazon Route 53, I can do this through the fargate CLI with one command. This hostname is now pointing to our load balancer, so let's open Chrome and test that through HTTP and HTTPS. And that's it. Thanks for taking the time to watch the demo. To learn more about the fargate CLI, you can visit somanymachines.com/fargate, and you can find the source on GitHub.